So we have person, we have main in the most obvious case, but we might have other types of agents, and in fact we might have multiple main classes that we can use at different times under different circumstances, as we saw for the ophthalmology example. So one of the best ways to hide details, to hide unnecessary complexity, is to create a class. The class takes responsibility for those sort of tasks, and all you have to know is what method to call in the class. You have to know what it does, not how it does it. And the class hides the details, say related to personhood, as far as main is concerned. All you know is, okay, it accepts this message. So you can send a person a message of this type, and it will get infected. How that infection takes place, all the details of state charts involved, whether it's multiple state charts, that's all hidden in person. When you need to change that, you can go to person and put aside the issue of how main is. So you can have these two different solitudes, as it were. So this is one way you can hide details as in classes. The second way is in methods, okay, or functions. And we're going to concentrate on that today. So basically, this allows us that will hide details about how a method accomplishes details, and it will allow us to use its name, parameter values, and some brief description to know what it does. Okay. So a method, for example, might compute a value. All we know is it computes a value. It computes the number of neighbors of this agent. We don't know how it does it. We leave to AnyLogic the responsibility of figuring out how it does it, and we leave to them the opportunity to change that over time between versions of AnyLogic. Maybe they figure out some super fast way of counting the number of neighbors. Sounds absurd, but actually there's ways of doing things like that with appropriate data structures. We leave to AnyLogic details on how it gets the ith connected agent to ourselves. That's up to AnyLogic. All we know is we have to call this method. If we give it these parameters, I has to be non-negative between 0 and the number of connections -1, etc., it will take care of the responsibility. So those are examples of things where it computes a value. It computes the number of connected agents, returns to us a reference to our ith connected agent. Another method might test a condition, for example. It might ask, is this person infected? So we can ask P, where P is a reference to a person, dot is infected. Now that judgment of whether or not they're infected might depend on multiple state charts. It might depend on one state chart. It might depend on variables they keep around. Who knows how person has defined it? All we know is that if we want to find that information, say in computing a statistic, we could just call P dot is infected. And we'll delegate to person the implementation of person, implementation of is infected, how that's done. So in short, testing some condition, it might be a complex condition, it might be a simple condition. By wrapping it up in a method, we can avoid hard coding dependence on that condition. And that will allow person to evolve. For example, to use 2 state charts instead of 1. To have a especially quick way of remembering whether or not they're in one of several infected states. It can evolve without our code that in our statistics from changing, because all it calls is P dot is infected. Is infected could evolve as long as it still returns information on infection status. Another method might perform some update on a person. For example, it might infect a person. So you could say P dot, infect. Or it could simulate the change of state resulting from some complex medical procedure or transmit infection to another. Alternatively, it might return a representation, like a string that returns information about a person, their name and serial number or what have you. Okay, so why use functional abstraction? Well, easier modifiability. There's only one place to update. If you change how it's done, you just change it in one place. We might have several statistics which ask, is infected on a person. one might ask if they're currently infected. One might be seeking to return the number of people that are currently or previously infected or what have you. And we might call this from many places within our model. If we directly coded the condition for this at each of those places, we'd have to update each one in turn. And that leaves a lot of room for error. Here we have one place to change it in the method. Transparency, giving it a nice name and calling it is often a lot clearer than putting in the whole complex condition, which we have to puzzle out every time. And it's easier to reuse later because you reuse it in many different places. And this reduced complexity lowers the risk of error.